2.6 today, and that book work and the written work. So there's always two things that are due every day that should be scanned into one PDF document, and that's the book work, which we mainly do in class. And I will put all of that up on Blackboard. And if you're having any trouble finding anything on Blackboard, just let us know and we'll show you where it's at. And then also the written work, which is the worksheet piece. So there's those two things. Then there is a study review that is posted. There is a review that's posted on Blackboard, and there's I think 20 through 24 on that review are not applicable to this test, but most of it is good questions. So if you want extra review material, that's where you should go look at the review. It's under the homework. We will take questions and continue to review on Wednesday. Matt's going to be doing that. Make sure to take the practice test. So when I talk about that, I'm talking about the Respondus thing. So you know what you're doing on Thursday. The test is Thursday during class time. There are no retests, are no makeup tests. If you've not gotten, if you don't show up for the test, then you get a 0 on it, unless you've talked to Matt or myself prior to the test. So make sure that that's highlighted on your calendar.
When you take the test, is there like a specific time, or how does that?
Yeah, you'll have an hour and a half, I believe. Is that right, Matt?
Okay. Yeah, it should be all during like your class time. So I'm hoping you go there like during class time and take it during class time.
Right. And then I think what's going to happen, someone was asking, I think it was Hunter. Because it's a real convoluted kind of how we have to do this. But I think what's going to happen, and we'll verify this for sure tomorrow, but I'm almost positive this is true, is when you finish the test, you'll get off Respondus completely. And then you have 10 minutes to submit it on Blackboard via how you normally do it. So does that help?
Yes, thank you.
Okay.
So what is it going to be, like a document we're going to download or what?
Yeah, it'll be on the test. You can print the test and write directly on it, just like we've been doing. Or you can, if you don't have a printer, you can just do it on a piece of paper, just like we've been doing the homework assignments. And then you're not going to have access to any of your technology throughout the test. So what you're going to have to do is stop Respondus, get out of the test, and then submit it through Blackboard. So once you are off Respondus, you'll have 10 minutes after you exit out of the test and exit out of the program to upload your test and send it to Blackboard. Does that sound right, Matt?
To be honest, like I don't know how it goes from the student.
I just read this. I mean, they just realized this is going to be an issue, and they sent us those directions. So if that's not the case, if I'm wrong somewhere, I'll let y'all know for sure tomorrow, because this is all like brand new to us too. We're like, anyway. All right, then today, this is the agenda. We're going to do a quick Kahoot review. This will be over everything we've done up to this point. And what I did is I actually looked at the test. I wrote the test this time and picked questions. These aren't exactly the same questions, but very, very similar types of questions that are on the test. So it would really be a good idea to participate. Then we're going to go through a quick overview of the inequality notes, which you hopefully watched last night or yesterday and took. And then I'm going to show you where a little 2.5, 2.6 like little cheat sheet is that you can use. And then we'll do breakout groups. And then all today's book work and the recording will be on Blackboard after class today. Will you make sure it's recorded, Matt?
Yeah, it's recording.
Okay, perfect. All right, so I'm going to go ahead and put up the Kahoot. And it's short. It's loading. My internet's been slow today for whatever reason. Hopefully because it's about to rain, and that always causes issues. I don't know what's going
Do you know off the top of your head if there is anything that's incompatible with the software that Respondus uses? Like,
on. I don't know.
Yeah,
okay.
so someone's telling me they're
I
having
think it just
problems with.
shuts down everything.
Someone's telling me they're having problems logging in with their iPad. I was wondering if anybody else is having that issue, or that it's having difficulty with the logging in with the tablet in general. I think maybe.
Yeah, I don't think you can use it through a tablet. It's either you can do it like on your like a MacBook or any other laptop with Chrome. I've realized it's the best.
What was the code?
Hold on, I'm trying to get it
Oh,
up.
oh.
I'm sorry, my internet's acting crazy. Well, we may just have to not do it. Dadgummit. Here, hold on, here we go. Internet is not. Okay, well, we're just gonna have to, maybe we'll do it another time because I can't get it to come up for whatever reason. So let's just go right into, I don't know if there's something with their website or it's what it is, but let's go ahead and just start right in with the notes. Okay. Okay, this little sheet right here is on Blackboard. And you can find it if you want it. Screen sharing. Can y'all see my the notes up here? Do y'all see this? The inequality notes?
Yes.
Okay, perfect.
Yes.
Okay, so this is going to be just a quick overview of inequality notes, and hopefully y'all watch the videos. So basically, when we have an inequality, if you make sure that you get the variable on the left-hand side, then the inequality symbol will tell you which way to graph it. So for example, this says x is less than 5. And you know that's less than, the little inequality sign is like this, which kind of looks like an L. And that tells you to graph it where it's pointing in that direction, in the direction that the inequality symbol is actually pointing. So on this one, you start with a 5, and you're going to be pointing to the left. And notice that in this case, there is no little equal sign. There's, like on this one, there's a little equal symbol. This one does not have an equal symbol. So that means the 5 is actually not included. That means that it doesn't include 5 in the graph. It goes all the way up to 4.99999999999 infinity, but 5, the number 5 is not included. And then it's going towards negative infinity. That just means it's getting, the numbers are getting smaller and smaller and smaller and smaller as it goes to the left. And this right here would be the interval notation. And to write interval notation, you always read from left to right on your graph. And this is where you start right here. And this is where you stop right here. And anytime you have infinities, there's, these are called open brackets. And this is called a closed bracket. Infinities always have an open bracket, whether it's from negative infinity or whether it's going to positive infinity. The only difference between this first inequality and the second one is that we've got the little equal symbol. And so that means that the 5 is included. So it's graphed exactly the same way. It starts at 5 and goes to negative infinity. Only this time there's going to be a closed bracket on it because that tells us that the inequality, the 5 is included. And notice the only difference in the notation is you start at negative 5, and I mean you start at negative infinity, so you have the open bracket. Then this piece right here is represented by the comma, and then the 5, and then you close the bracket. So
use the circle.
You can use a circle if you want, like if probably in, actually, I don't know about you, Matt, but Algebra Express is the only class I've ever seen where they use the parentheses and
the brackets, yeah.
Usually, and you're welcome to do this if you're used to doing like an open circle and an open and a closed circle to indicate the inequalities, you can do that too. Either way, okay?
Yeah, I mean, I've seen the brackets and parentheses, but I see the circles way more, to be honest.
Way more, yeah. I like I said, I've never ever seen the brackets in the. I was like, what? When I first saw that, but now I'm used to it, so it's no big deal. So either way is fine. Just make sure you're very. I think what's nice about the brackets and the parentheses in a way is that it matches the interval notation so well. But again, that's a personal preference. So here we have x is greater than 5. So notice that the inequality symbol is pointing to the right. And the greater than symbol, this is, well, I think that's it's not nearly as nice as the less than. So the greater than here, we're going to start at 5 and go to positive infinity. And again, there's going to be an open bracket or an open circle. And the when you go to write the interval notation, you start with the 5 and the open bracket, and then you put a comma, and that represents all the rest of the numbers in between. And then you finalize it with the infinity, and the infinities always have open brackets. And remember, you're always reading from left to right. Okay, greater than or equal to 5 is exactly the same as this one, only it's got the closed bracket and it goes to infinity. This is written, or is actually stated, x is between -5 and 5. So when we go over here, we're going to put -5 and 5. And the shading is going to be between those two numbers. And this right here tells us you either have an open dot or an open bracket. And this right here tells us we've got a closed bracket. And then to write that, you start from left to right. You write the -5 with the open bracket, and then 5 and close the bracket. This one right here means that x is outside of the numbers that are given. So it's going to look like this with a space in between. It'll be going away from each other. So here again, we're going to start at -5 and go to the left towards negative infinity. And then we're going to go to 5 and go to the right towards positive infinity. The -5 will have an open circle or an open bracket on it. The 5 will have a closed bracket on it. And then when you write this, it's going to look like you'll start from left to right. Start with negative infinity. All the infinities always have an open bracket, comma to -5, close the bracket. Then this little, it's a union symbol. It means or. Then you start back up with the 5, and it's got a closed bracket and go to infinity. Okay, so I want to show you. So this little sheet is on Blackboard. Another one that I think is helpful that I put on Blackboard, I'll show you, looks like this. This kind of tells you, just if you ever get confused, you can just kind of look and see all the different steps to solving an inequality. What I also like about this is that it gives you some inequality vocabulary. So if you're ever unsure, what does that mean? If they say fewer than or shorter than or a maximum of, you can kind of look at this little sheet and it'll tell you what the inequality vocabulary is. So before we jump into the working in groups in the book assignment, I just want to give y'all a couple of quick examples. We're gonna kind of break this into parts. The first parts are just very basic inequalities that only have one variable piece to them, and you're not trying to combine like terms, you're just solving an inequality. So when you solve an inequality, you do it exactly the same as if you're solving a regular equation. The only difference is that if you multiply or divide by a negative number, the inequality will flip. That's the only difference. So let's look at just these four real basic examples, and then I'm going to let y'all work on some of the homework assignment. So here we have x minus 3/5 is greater than or equal to 9/4. So just like before, we want to get the variable on the left, or I do. I usually want, especially when you're working with inequalities, it's important, I think, to keep the variable on the left, because then you can tell, otherwise you're not going to be able to just look at the symbol and tell which way it points on the number line. So I'm going to add 3/5 to both sides. But before I do that, I'm like, I don't like this fraction. So I'm going to multiply through by the LCD, just like I would in a regular equations, just to get rid of the fraction. And the LCD is going to be 20, because both 5 and 4 will divide evenly into 20. So I'm going to multiply everything by 20. And that's going to give me 20x minus 5 goes into 24 times. 4 times 3 is 12, is greater than or equal to, 4 goes into 25 times, 5 times 9 is 45. And now I've cleared the fraction, so now I'm going to add 12 to both sides. And I get 20x is greater than or equal to 57. And then I just divide both sides by 20. And I get x is greater than or equal to 57 over 20. All right, so this is the inequality notation. The graph, we would start at 57 over 20, wherever that is. This tells us that we're going to have a closed bracket, and it's pointing going to the right, towards positive infinity. And then the interval notation if you look at the graph, I always think it's easiest to do the graph first, because then you can totally just pull off the graph the the open bracket, the 57/20. This piece right here is indicated by the comma, and then the infinity, and you always have an open bracket on your infinities. You always read the graph from left to right. So here on number 2, if you divide both sides by -5, you just have to remember that anytime you multiply or divide by a negative number, the inequality will flip. So here we have y is greater than -8. And again, when we graph this, we are going to draw our number line. We're going to start at -8. It's going to be pointing to the right, and it's going to be an open bracket going to positive infinity. So reading straight off the graph from left to right, we're going to say -8, comma, infinity. Now this one, anytime you have a variable on the right-hand side, I would immediately try to get it on the left-hand side. So I'm going to write 3/2 k over here and the 9 over here. When you do that, you have to flip the inequality as well, because it needs to be pointing at the same number it started out. Since it's pointing at the 9, it needs to continue to point to the 9. Okay, and then you would do that one just the same as you did number 1. And then here, this is called a compound inequality. And all this says is x is between -2 and 5. So on the number line, we'll have -2 and 5. This tells us that we have a closed bracket or a closed dot. This tells us we have an open bracket or an open dot. And the shading is everything in between those two numbers. And the interval notation would just be closed bracket -2, the comma stands for all of this stuff in between, and then the 5, and then open bracket. So from left to right. Okay, so now we're going to spend about, I don't know, 5 or 10 minutes in groups. Yeah, question?
Yeah. I just want to make a comment. There is apparently there's an option in there to allow you to take it through an iPad. And I went ahead and set them all up. I went ahead and changed all the tests and all the settings. So you should should be able to access it with an iPad. And I also threw, there's also an option for a scientific calculator in there. So you should also have access to a calculator.
Good. Good. Thanks, Matt.
Yeah.
All right. So will you split them into groups? Can you do that?
I cannot do that.
Oh, you cannot. Okay. So let's see how adept I am at this, which is not really very much.
305, I don't see it on there.
305. Oh,
Yeah.
oh, that reminds me too. Okay. Also,
We're doing book problems, right?
Oh,
if you want, I set this up for you guys. If you want to use it, you can just take it straight out of the book. If it's in there also. So you can either look at that, or you can look at this. Oh, well, I left 305 off of this one, so I don't know why, but it's on this one. So, so what we're doing right now is 297, 301, 305, and 307. So it's really just the first page of this grouping. Okay, and I'm going to go ahead and group y'all if I can figure out how to do this.
We're doing book problems, right?
Yes. Okay.
Okay.
Break it up. How many people do we have? 18. So I'm going to put y'all into five rooms. What did you do yesterday, Matt? 4 or 5?
5.
Okay. 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 And I'll let you know when I'm going to call you back in. Let's see options. Okay. I hate it when there's computer glitches. I mean, just kind of takes whatever you've planned and throws it out the window. Oh, well.
Can I do? Hmm. Yeah. I have to stop real quick. Are y'all getting this?
Yeah. Yeah, we're getting it.
Where are these people? Most people aren't joining the groups. Can y'all see the other groups, or is it just like, I don't know what y'all's view looks like?
We just see that there's like 4 people in here.
Okay. This is like some people haven't even joined a group. Like, well, there's one person now. Okay, there he goes. Yeah, so I know I said it in the video, but the best advice I have for these is really like draw that graph.
Yeah, I'm drawing the graph and then I'm putting like the points.
Yeah, because a lot of times they'll ask you to like convert from what the inequality to like the interval.
Mm-hmm.
But like, I don't know, people tend to mess that up way more than if they just draw a graph and do like, because the graph really acts as the middleman for some reason. I'm not sure, but like people just see it a lot better. Okay. Which way is this going? This way? Ooh. Can y'all see that? Is that visible?
Yeah, we see it.
All right. You have any questions about like how to draw these things? What she say we're working on?
She said we're working on 297, 301, 305, and 307.
First page.
Mm-hmm.
Can I even see where she's at? Where's she at? Oh, she's in room 5. Okay. That minus 0.5? One third. Okay. Yeah. Yeah, I don't know what she said. I was like trying to do some test settings when she was like talking, but like I'm not like that picky about like how many numbers you're putting on here. Put a few, right?
Yeah.
There should probably be at least like 3. The number that you're gonna circle and then the one above it and below it. Yeah. I don't know. Where's that pin? So what'd you get for the first one?
For the first one,
Yeah.
I had an open circle, went all the way to the right. 3 with infinite.
Open circle to the right.
Mm-hmm.
And like infinity.
Both sides parentheses.
What you're talking about?
Yeah.
What do you call these? Parentheses and the other one's brackets? Is that what you call them? Okay.
Yeah. I call
Yeah,
it
sometimes I say soft and hard parentheses. Sometimes I say soft and hard brackets. I was just making sure. I thought that's what you meant, but
that. Yeah.
yeah. I kind of say them interchangeably, so I'm a little weird, but okay. These things. That one's horribly drawn. Okay. What do these look like?
Like you put numbers.
What was that?
Oh, I see them. Yeah. You put numbers like 0, 1, 2, -1, -2. Oh, I haven't finished them yet.
Okay.
That's only got the second set. 301.
One minute. Okay. Okay.
Well, the 0, it's an open circle, goes all the way to the left to -2 with a open circle.
Open circle goes to the left. Okay. Yeah. Yeah, so these look like these are like these intersection things, right? They're just like, these things look like they shoot off to infinity.
Yeah.
If we have two things that shoot off to infinity, like one that way and one that way, we can kind of like intersect them, and their intersection looks something like this, right?
Mm-hmm.
Or they're bound by two numbers is another way to look at it. These ones should be like really easy to write, this sort of thing, right? This one almost fills out itself to me. It's like, how far left do we go?
-2.
Yeah, -2. How far right do we go? 0. Yeah, I think we're coming back together in a minute. Okay. Maybe.
Yeah.
30 seconds. 59 seconds.
I mean, do you want me to tell you how I would do B or C?
I would like, if you can do it in 45 seconds.
So for B, it's -3 all the way to -5. The -3 is an open circle. The -5 is a closed.
Yep, that's it.
And then C is 3.5. That is a closed circle all the way to 0, which is a closed circle.
Yeah, 0 to 3.5. I drew my scale really horrible on this one. I started running out of room, make them really small. It's like that. Oh man, it reminds me of the St. God's Hospital on Idiocracy, where they just like run out of room and start writing it all sideways.
Oh, 1A.
Huh?
Would there be 3 I guess like 3 commas for values? Like it would be possibly -2 what is it? Like infinite? Is that infinity
No,
or
no.
zero?
Okay, so whenever it's written like this means X is between -2 and 0. So all you do is you write your -2, you write your 0, and then you put the shading between them. And then they're both going to be open, right? Because neither of those have the equal symbol on them.
Okay.
And then when you write this in interval notation, you take it straight off the graph. From left to right, you'll write your -2. The comma stands for all this stuff in between, and then the 0.
Oh.
Okay, so anytime you have an X between two numbers, that's how you do it.
Okay.
Okay.
So what about the unity, the U letter thing that we would put like in between two parentheses?
Actually, we didn't have any like that on here. You'll see that on the next set of examples. The unity, though, what that is if you had something like, for example, X is less than -5 or x is greater than, say, 7, you would have a number line. And you've got two distinct parts, right? That means there's going to be a gap between them. This first part, you would just graph x is less than -5. And then the second part, you would graph x is greater than 7, just like you would normally. And then you would just, when you're writing this in interval notation, you would just take it straight off the graph. You would go from left to right. You would write -infinity, comma, -5, close the parenthesis. Right here is the u. And then you go 7 to infinity. And we'll have a problem like that in this next set.
Yeah, I was gonna say, like, I don't know if you can see my screen, but like the thing that we just drew, you can think of it as the intersection of sets, actually.
Mm-hmm.
And so what we're doing is we're taking things that are infinite sets, like from -2 to infinity and from -infinity to 0. We're like intersecting those things, and then we're gonna get that set from like -2 to 0. So we're like, it's kind of subtracting sets, or part of the set. It's taking the overlap of two sets. So we're actually like reducing the sets when we do this sort of thing. The other thing, when we union sets, we're combining two sets together. So it's more like we're adding sets, or we're adding more to our set.
Any other questions on these? And I will post the correct answers, but if y'all want to see any right now, we'd be glad to do it on these first 4.
Can you do, which one was it? It's 301B.
Okay, so 301B, this is saying x is between -5 and -3. So you put your -5, and this should be an open, right? This tells us we have a closed bracket on -5. This tells us we have an open one on -3. And this says x is everything in between those two numbers. And then to write this in interval notation, we do exactly the same thing. We take -5 and then comma and then
-3 on the number parentheses.
Right. So really the interval notation really strongly resembles the graph. That's why I like to do the graph first and then the interval notation.
In what case will you, I'm just kind of confused by the infinity. What situation would you have that?
You only have, okay, so this is actually, and that's a good question. These kind of problems like 301 are the only time you won't have an infinity, okay? Because it's an intersection and it goes between 2 points. So these are the only time you will not have an infinity. These you will always have an infinity. This just says x is greater than 3. So you'll put your 3 and you'll go to infinity and that's it. And so you would be 3, comma, infinity, right?
And we
This
don't go
says-
beyond.
So the only time you're not going to have an infinity is if you have x between 2 numbers. Does that answer your question?
Yes, it does.
Okay.
So
I have
it's
a question.
fairly, sorry.
No, go ahead.
I just want to make sure that this is fairly simple. We're not figuring out anything. We're just graphing it and then writing it out, whatever it is from left.
That's what we're doing. That's what this first set of problems basically is. It's pretty simple. I mean, the hardest it got to, I mean, we have some fractions going on here, but once you clear the fraction, it turns into an easy problem, right?
Yeah.
So like for number 10, what would you multiply this whole thing by to clear the fraction?
48?
You could. Y'all, if you can't figure out the lowest common denominator, 24 would be the lowest, right? But you can always say, what's 8 times 6? You can always multiply the denominators, and that will give you a common denominator. It may not be the lowest one, but it will still work, okay? So 24 works. It's the easiest one to use. But if you said 48, that's okay too. So then you'd have 24b, and then 8 goes into 24 3 times, and 3 times 7 is 21, is greater than or equal to 6 goes into 24 4 times, and 4 times 1 is 4. And then you're going to subtract the 21 from both sides, so you get 24b is greater than or equal to negative 17. And then divide both sides by 24, and you get b is greater than or equal to negative 17 over 24.
So basically, for so you just gotta, for the fraction ones, you just gotta find the least common denominator, multiply the least common denominator on both sides, just cross
Right. If you want a
multiply
common
whether
denominator, yes, if you want the lowest common denominator, you have to kind of think about it a little bit. But if you
yeah,
want,
and then
if you want a denominator, you can just multiply those two numbers together, and that will give you a denominator. And that will a common denominator. It's not a
yeah.
lowest, but it
Yeah.
will work, right? It
So
will work.
basically, like it crosses out the denominator, so you just get like one single number, kind of.
That's right. You don't. That's
So
why
like,
we're not clearing the fractions.
and then you multiply the numerator with the number that's the denominator needs to be multiplied by to get, you know, the common denominator. It's like 6
That's
and
right.
8, 24.
Right.
Multiply top one by. All right, I see what you mean.
Right. So like
Sorry
on,
about that.
no, you're great. You're great. So like on 307, the lowest common denominator is 36, right? But because 12 goes into 36 and 18 goes into 36. However, if you didn't think of that, you could say, okay, what's 12 times 18? Well, that's going to be an ugly number, but it will work. Okay, it will work. And then here we'd say 36 times g is 36g. And then we say 12 goes into 36 3 times. 3 times 11 is 33, so that would be minus 33 is less than 18 goes into 36 2 times. 2 times negative 5 is negative 10. And then you just solve it from there. Okay.
Okay, are we supposed to flip the sign? I'm asking them this.
Would we flip the sign? Inequality symbol?
Would it be yes, because we're dividing, or because they're negative numbers?
No. The only time the inequality symbol flips is when?
When you divide
By
by the number all the way to the right.
no, okay.
Can
So
you
the
divide by a negative number?
or what else?
Or when you switch sides?
Well, yeah, that's a good one. Yes,
Yeah.
if you switch sides, you flip it. Right. Is if you take one part and put it on the other, like where's one? Like right here, you would write 5/8 k and 40, right? And what would happen to the inequality? Which way is it pointing now?
It's pointing left.
It started out pointing left.
Oh no, it's going right. My
Yeah,
bad.
but
I
now
got
it's going
confused.
right. So if you flip it, you have to flip the inequality as well. But what mathematical operations cause it to flip is if you multiply or divide both sides by a negative. Okay. So you can add negatives all day long. You can multiply by fractions. You can multiply by whole numbers. The only time it's going to flip is if you multiply or divide by a negative.
So how would we clear the fraction for C in 305?
Okay. Okay, so how would you, what do you think you would do on C? What's the only denominator?
8?
Yeah, right. Well, 40 has a denominator, but it's 1, right? So if there's just one written denominator, that's what you multiply by.
Okay.
Okay. Okay, so let's move along to, let's look at some examples of the next few problems. Okay, so here, notice what's different about number 5 than the one that we've been doing.
It's like one step solution kind of. You gotta like add or subtract the how do you call them, factors, like the x's, like
Right,
the number
we've
had
got,
x's.
right, we've got x's on both sides, right?
Yeah, so basically it's like 1 or 2 step solution if I'm correct. Kind of doing that.
Right.
PEMDAS.
So what do we have to do on this one? Just
I'm
solve
not sure if
it.
that's a 13 or a 12 because it's crooked,
That's a
but subtract
13.
it. Oh, sorry.
Yeah, that's okay.
Subtract
Right. So just like before, now does the inequality symbol flip?
No,
No. Why?
because it's still negative, and it's
You're
on the
not
left side.
yeah, you're not multiplying or dividing by negative, right? You're subtracting
Yeah.
from both sides. Okay.
Oh, so it only flips when you multiply it.
Or divide.
Oh, okay. But
Yeah. You can add and subtract all day long and it's not going to change. Okay. So, so this is going to be negative 10x is greater than or equal to negative 50. Now what will we do?
Divide by negative 10.
And what's going to happen?
Sign flip.
The inequality will flip because we're dividing by a negative, right? So we would get x is less than or equal to 5. Okay. Now again, this is, it'll have an infinity. The only time it's not going to have an infinity is if you've got x between two numbers. Okay. So when you graph this, it would be, you'd say you're 5. You would have an open bracket pointing to the left towards negative infinity. And if you write that in interval notation, it would be negative infinity to 5.
Yeah, it might be like beneficial to kind of compare and contrast that to like the previous thing, because I think like the thing that's confusing them is that there's a negative number that we're multiplying, but the negative number is already there. Here it's not there. We're multiplying by the negative or dividing by the negative. It's the thing that you're using to operate with that we're looking at.
Right. Like for here, if you look at this one, we have 7x and we'd have to distribute the negative 5, right? Well, we're multiplying a negative 5, but not both sides, right? So that's just going to be minus 5x plus 25 is greater than or equal to, here, distribute the negative 12. These look horrible, but they're not.
I think it should be 10x.
Oh, it should be, thank you. Okay, remember that when you distribute, like this negative 12, this parenthesis tells you where to start, and this one tells you where to stop, okay? So you wouldn't multiply the negative 12 by the 9x. All right, then we're going to combine like terms, and that would give us negative 3x plus 25 is greater than or equal to, here we've got negative 3x plus 12. Whoops. Oh, I think I made up a bad problem, but this could happen, I guess. So here, if I add 3x to both sides, what happens? I get a 0. And if I subtract 25 from both sides, I get negative 13. Oh, and is that a true statement? Is 0 bigger than negative 13?
Yes.
Yes. So that means what would the solution set be if you get a true statement? Remember from back when we were doing it with equations?
That would be all real numbers, right?
All real numbers, absolutely. And I'm pretty sure this does happen in your homework somewhere. Okay, now if you have a 3-part inequality, you're still trying to get that x all by itself, only this time in the middle, okay? So if you just looked at, let's just look at this piece right here and pretend like that 11, I'll put it back on there in a minute. What would be the first thing you would do in this case? And I don't want to flip it to the other side because it actually is in the middle. But what we do to get that x by itself first?
Add 9.
to the.
Add 9, right. Okay, so good. So I'm going to go ahead and put this back on there. Minus, what was the problem? It was
Is this your sheet or, because I'm trying to look for these from my printouts
no,
here.
these are just examples.
Oh, okay, okay.
Before we jump into the groups. All right, so what we're going to do is add 9. But do y'all see we have to add 9 to each part, right? So if you add 9 to the middle, you have to add it to the left-hand side and to the right-hand side as well, because there's 3 parts to this inequality. So that's going to give me positive 3 is less than or equal to negative 3x, which is less than or equal to 18. And then what would I do?
Divide by -3.
You divide everything by -3, exactly. And you have to divide every single part by -3. And what's going to happen?
Signs flip.
What?
Sorry, signs flip.
The signs flip, right. We're dividing all parts by -3. So the signs are going to flip, and I'm getting -1 is greater than or equal to x, which is greater than or equal to -6, right? Now, what you've got to be really careful with about this is when you put this on the number line, which number comes first on the number line? Which one is the smaller of the two numbers between negative and -6?
Oh yeah, if it's on the negative side of the number line, the number closer to 0, the more bigger technically it is.
That's right. So what would be this? What order would you put these in on the number line?
I would say like -6 and -3.
-6 and
-3.
not -3, but what's the other number? Not
Oh,
negative.
-1. So -6, -1, 0,
Right.
1, etc.
So that's what you have to be careful of, guys. When you multiply or divide by negative and the inequality symbols flip, when you go to graph it, don't just graph it in the order that you see it in the inequality. Make sure that you put it in the right order. Okay. Okay, and then lastly, there will be one like this: x is less than or equal to -1/2. So when you write this on the number line, I'm going to graph this piece first. So I'd write -1/2, and the shading would be going to the left towards -infinity, and it would have a closed bracket. The or just means there's going to be a space on the number line. And then you're going to start with 5. And it will be pointing to the right towards positive infinity. Like that. And then when you write this in interval notation, my infinities for some reason are looking like 8s. I don't know why. You're just going to read it from left to right. So you'll go -infinity, comma, -1/2, close the bracket. And what represents the blank? What do you put now? What stands for 4? What?
Is
U.
it like a
U, right, it's the U. The U stands,
I
it's
thought
a
U stand for unity or
union.
together.
It's a union symbol, right? It means or. It's the mathematical symbol.
Oh, I see. My bad.
You start with 5 and go to infinity. Okay, so we only have, this class goes so fast, 15 minutes. So let's, as a class, let's go through the next few problems, because it takes me so long to get everybody into groups. All right. So if I call on you to tell me what to do, don't let that intimidate you. Just say, I'd rather not. And I'll say, okay. But let's see, Aurora, could you
Yes.
tell me how to do number 13?
I was wondering because there's two U's, so
Okay, good, good. So what would you, how would you get those together on the same side? What would you do?
maybe subtract the 8U.
That's perfect. Yes, to get rid of a plus 8u, because this is a positive 8u, you're going to subtract 8u from both sides, right? Great. Now what would you do?
Now you would divide by -3.
Beautiful. And what happens when you divide by negative?
You would flip the sign pointing to the right.
Perfect. So you're going to have u is greater than or equal to 7, right?
Yes.
Okay, so the graph, which way is the graph going to be pointing?
Towards the left.
To the
Left to negative. Oh, no, the right side.
right, right. See the inequality is pointing to the right? That means your graph is going to be pointing to the right, okay? So we know the graph is pointing to the right towards what? Where's it going towards? Which infinity?
Positive.
Positive, And then what kind of a bracket here? Do we have a closed or an open bracket?
Closed.
Yeah.
Yeah.
Beautiful. And then how would you write that in interval notation?
Close bracket 7, comma, infinity.
Beautiful. Awesome. Awesome work. Thank you. Timothy, would you do number 323 for me or tell me what to do?
No. Well, on the left-hand side, we need to distribute for starters. Distribute 5 to 2u. So it should come out to 9u plus 25u negative 25.
9u plus 10u, you mean? Minus 25.
Right. My bad.
Okay,
Sorry.
got it. Yeah, that's fine. All
On the
right.
other side, sorry?
No, okay, now what?
Okay, so on the other side, you know, they put distribute 12. Is that a y or a u?
That's I was raised in the day where my handwriting is totally cursive, so sorry about that.
No, it's all right. My handwriting is terrible too. But yes, you're going to distribute.
I wish I knew how to write cursive, but I can't.
All right, and then what?
And well, don't forget to add the 7u in the equation.
Perfect. Okay, now what?
And now, preferably I like to go left to right and isolate like terms. So 9u plus, sorry, it looks like a y. I'm sorry, but yeah, 9
okay. U or y, whatever, just as long as you're consistent.
Right, 19y minus 25. 19u. I am sorry.
That's okay. No problem.
Right, and so this one's going to be a bit tricky, but I always take the symbol in front of the number in the variable, so that's going to be positive. So 12u minus 7.
Okay, wait. What's the symbol in front of the 7? Right in front of the 7.
Is that a plus? Or
that is plus. This is a plus.
Right. So it's a positive.
Yes.
Right. So
it'd be 12u.
Would you subtract this since the number in front of the 12u?
Okay, and that is an excellent question, and a lot of people do that. But remember that the sign of the number is the sign that's right in front of the number.
Okay, so we're going to the sign that we're going it towards. Got it.
Right. The only time that wouldn't be true is if there were parentheses around the 12 and the 7u. Okay.
Right.
Okay.
Right,
So that would be a positive 7u. So just remember this: the sign of the number is the sign exactly in front of the number, and if there is no sign in front of the number, it's an implied positive. Okay.
So pandas, kind of.
So 12u plus 7u would be
19u, except it'll be a negative 12 plus 19u.
Right. And this is one similar to the one I just did.
Okay. So basically, our main goal is to like make the letter, the interval, or the fact. I said, but b by itself. To like instead of saying having like 5v, you just want to have v by itself as a letter.
That's right. That's right. Right. Exactly. That is the whole point of this, right? And so now what do we get?
Okay, so I'm sorry to cut you off. You would subtract 19u to the other side.
Mm-hmm.
And then you would add negative 25 into 12.
Add 25 to both sides, right?
Right.
Okay. And what's that going to give us?
13.
Okay. So we get 0 is greater than or equal to 13, right?
Yes.
Is
And
that
it
true?
would be all real numbers.
Yes, all real numbers. Okay. Now, how do we graph all real numbers? Do you know?
What?
No. Usually
Okay.
I rely on my calculator for that.
Wait, what's the
Okay,
solution to that one?
All real numbers.
0 is greater than 13?
Oh, is it? I thought it was negative 13. Thank you. Yeah, that's not. No, read. Thank you. So 0 is greater than or equal to 13. Is 0 greater than 13? Is 0 greater than 13?
No.
No. Is it equal to 13?
No.
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 This is a false statement, right?
Right.
So that would be no solutions. Okay, so here's the deal, guys. If you have no solutions, that is just an empty number line.
So that we know you graph it, right?
Right, and there is no, so the interval notation is just nothing, okay? Now,
Okay.
if it had been all real numbers, okay, if you do get all real numbers, then the graph of that is the whole number line, like that.
So it would just be one straight line going in both directions?
Right, it would be, and shaded, right. And then the interval notation would be from negative infinity to positive infinity.
Oh yeah. Oh yeah.
Okay. So if it turns out to be a false statement, then there's no solutions, and it's just a number line with nothing on it. And guys, though, let me just caution you, when you get something like this, don't just leave it blank. Make sure you say no solution. Otherwise, I don't know, or we don't know that we just might not, we might think you just don't know what to do with it. So make sure you tell us that you know it's no solutions, okay? Okay, Dakota, would you do 329? Dakota there? Okay. Paige, would you do 329? You know how to do it? Oh, let's unmute you. Okay.
Sorry about that.
So this is 35 times k is less than or equal to negative 77. So what would I do here?
Divide.
By what?
30. Would you divide by 35?
That's right. Is the inequality going to flip?
Yes.
Okay. Why?
Because you're dividing and.
But are you dividing by a negative?
But, well, you're dividing the other side by a negative by a positive, so would
Right.
that not?
Yeah, good. That's what we're trying to point out to you. This number, the number that you're applying to both sides, if you're multiplying or dividing by a negative, that's the only time it'll flip. It doesn't matter if there's any other negatives in the problem. Okay. So so that won't flip, right? Because we're dividing, the number that we are actually dividing by is positive. If we were dividing by negative 35, it would flip. Okay. So that's going to give me k is greater than or equal to negative 77 divided by 35. And how would I graph that?
I'm not would you leave the fraction? You would leave it as a fraction?
Oh, yeah, absolutely. Especially if it's that ugly, right? I would for sure leave it as a fraction.
You'd graph it very carefully.
I would put a closed bracket
Mhm.
on the left side and then put K and then have an open bracket on the right.
Okay, the only time you're going to have the actual variable is this piece. After that, there's no, you don't put any more variables. You know what I'm saying? So K, once you finish this, that's the only time you're going to have a K or a variable anywhere in your problem.
Okay, it would be infinity.
It's going to go to positive infinity. And what's the number that's right here?
Negative 77 over 35.
That's right. And you don't want to have the K anywhere in there. Okay. And then how would I write that in interval notation?
Negative 77 over 35 is greater than.
Okay,
or,
so
it would.
Interval notation is going to have a comma.
Yeah.
So comma, and then what?
Infinity.
Yes.
So depending on if it's a positive or negative, like variable or infinity, but let me form this question the right way. If you have a negative number instead on the bottom of the fraction versus like having 35, let's say it was 35 over negative 77, would that be set on the graph differently, or would it still be on the negative side of the graph?
So if you have, let's say you had negative 5 over 4. That is the same thing as 5 over negative 4, which is the same thing as negative 5 over 4. Those are all the same.
Okay.
Okay.
So the signs only switch when they're both negative numbers?
When you multiply or divide both sides by a negative. So let's look at this one right here. Chris, you want to do this one for me?
Yeah.
Okay, what would you multiply? Okay, I'm going to shut up. So what are you going to do first?
Well, the one that says 21 over 8. Why? That one?
Uh-huh.
All right. So what you're going to do is try to find the least common denominator between 8 and 28.
Great.
Which I would believe it could be 4.
Okay, so 4 is the number that will divide into both of them. But you want the number that they will divide into.
So 28.
Okay, will 8 go into 28?
No.
No. So take 28 and multiply it by 2. And that gives you 56, right?
Yeah. Oh, so 56, that'll be 7. 7 times 8.
Yes. So what's the lowest common denominator?
56 then technically.
Yes, 56.
I think you can use the same number though. I mean, or you can't.
Not always. Only if it will go into that. You can only use that number if the other denominator will divide into it.
Oh, I see. My bad. I got confused because like I remember like something about like you can like use it, like if you had like 26 and 4, you can probably use 26 and like that. But never mind.
And a lot of times that works, but not always. Okay.
Yeah.
Now we need to get rid of the negatives. So how am I going to get rid of the negative? Can I do that too in this one?
I guess what you can do is multiply negative 7 with negative 21 and make it a positive.
Okay. So let's do that first then before we do the 56. Do you want to? You can do it in one big step. But let's say we want to get rid of the negative first. So you would multiply both sides by -1. Is that what you're saying?
No, I was gonna say because you know how 7 times 8 is 56, and the least common denominator is 56. So I was saying like -7 times -21 because 56 goes into 8 7 times. So multiply.
So are you
7.
saying to multiply by -56?
Yeah, and then like on top multiply with -7 on top of the numerator.
Okay, so 8 will go into -56. How many times?
7 by 7.
-7, and -7 times 21.
-21 will be negative positive.
-21. It's
Yeah,
going to be a positive, right? And it's going to be positive 147. And then on this side, when I divide negative 56 by 28, that gives me negative 2.
Negative 2. And then multiply negative 2 with negative 15.
And that gives you
Positive 30, I mean, my bad.
positive 30.
Positive 30.
Now, what we've done to both sides is we multiplied both sides by a negative. So what happens to that inequality?
It flips.
It flips.
Right.
Right.
Yeah. And then, but it's going to flip again because you're going to divide 147 by itself, I think.
That's right. And will it flip again?
Yeah.
Why?
Changes.
Are you dividing by a negative?
I'm sorry?
When you divide by 147, what kind of a number is 147? Positive or negative?
Positive.
So unless you're dividing by a negative.
Oh, I see what you mean. Oh, I guess so. It's not just about multiplication and division. It's basically if it's a negative or negative number.
That's right. If you're applying a negative by multiplication to both sides or by division to both sides, that's the only time it flips. Okay.
So basically, it only flips in the case of negative going to positive, multiplying or dividing.
That's right.
All right.
Okay, so then this gives us y is greater than or equal to 30 over 147. And you can reduce that. You know how an easy way to see if multiples of 3, because you can divide both parts by a multiple of 3. And the easy way to tell that is if you add the digits, like 3 plus 0 is 3, and 3 is divisible by 3, right?
Yeah.
So we know that 30 is divisible by 3. And then if we add 1 plus 4 plus 7, we get 12. Right? And is 12 divisible by 3?
Yeah.
Yeah. So we know that one's divisible by 3 as well. So that's a fast way to tell if a number is divisible by 3.
So basically add them up until and if you get a factor of, let's say 3.
A multiple of 3, exactly.
A multiple of 3, my bad. Yeah.
Yes. No, I know. So this is going to be 10 over, and 147 divided by 3 is 49. So that would be the reduced form of that.
Mm-hmm.
And how would you graph that?
Bracket, put like a bracket because it has an equal sign, so it's gonna be a hard bracket. It's gonna be close.
Good.
I will start off from there to the right infinity.
Beautiful. And I know, guys, that the time is up. So if you need to go, don't hesitate. I'm just going to keep going, and I will post all this stuff online. So.
And then you will write the interval notation as bracket 10 over 49 infinity, positive infinity.
Beautiful.
And then instead of making the bracket on the right side, just leave it as a little, normal.
Right. Open parentheses. Exactly. Good.
Dang, I'm actually getting the hang of this. I thought I was gonna forget about this stuff after
high school. Yeah. Right. You're doing great.
Well, hope you have a good one, Miss Lisa. I'll see you tomorrow.
Okay. Bye, sweetheart. Okay. Now, just real quickly, let's finish this out. N over 13 is less than or equal to negative 6. So hopefully everyone sees that we're going to multiply by what? What's the only denominator that you see in the problem?
13.
Yes. So is the inequality going to flip?
No.
What?
No.
No. Why not?
Because it's a positive.
That's right. If you multiply both sides by a positive, or if you divide both sides by a positive, the inequality stays the same. So this is going to give me n is less than or equal to, what is that? 78, negative 78. And then you just go from there. Now in the book, if you're reading in the book, and Matthew discussed this, the problem says x is less than or equal to 4 and x is greater than negative 2. And I just want to show y'all what that looks like so you can see it, that it actually is the same thing as x is between negative 2 and 4. So x is less than or equal to 4 on a number line would look like this. And x is greater than, x is greater than -2 would look like this. And means where they intersect. So where they intersect is from here to here, from -2 to 4. So that's why it's the same thing as saying x is between -2 and 4. Okay. And then you would just, and this should be an open one, -2, comma 4. Okay. This one, we want to get this x all by itself. We're working with a 3-part inequality. So the first thing we would do would be add 5 to each part. And that would give me 2 is less than 2x, less than or equal to 6. And then I would divide each part by 2. And that would give me 1 is less than x, less than or equal to 3. And remember, that means that x is between 1 and 3. This is the only time we do not have an infinity sign in our answer. It's just going to be 1, comma 3. And or means that we are going to have infinities and we're going to have a u. Less than or equal to -4 means that. Greater than 3 means that. So this would look like, starting at -4 going to -infinity, and starting at 3 going to positive infinity. This right here is a u. So when we write this in integral notation, going from left to right, we would say -infinity, comma, -4, close the bracket, union 3 to infinity. Okay, these are the last two from 2.5, but remember, you still need to do the problems from 2.6. There's 3 problems on 2.6. And I'm going to go ahead and, 2.6. I'm going to go ahead and do that, but it will be up also. So these word problems are really, the only difference between them and the ones that we've done before is that you're going to have to include an inequality. So 347 says, the elevator has a sign that says the maximum weight is 2,100 pounds. Okay, that means that you want the weight to be less than or equal to 2,100, right? Because if you get bigger than 2,100, then it might break the elevator. So if the average weight of one person is 150 pounds, how many people can safely ride the elevator? So I'm going to say let x equal to the number of people on the elevator. And we know that every one of those people, imaginarily or whatever, technically weighs about 150 pounds. So 150 times x, we want that to be less than or equal to 2,100. And again, if you're unclear about the verbiage, go back to that little sheet that I showed you, and it gives you all of that. And then you just solve this. You're going to divide both sides by 150, and 2,100 divided by 150 is 14. So only 14 people. Again, yeah.
I said it in the video, but like you could pretty much solve these things with like looking at them like they're an equation, and then just like kind of figure out the sign all along there. Because if you end up like, what if x is greater than 14 people, you know you obviously did something wrong, right?
Right.
it's like, yeah, that doesn't seem right.
It's logical, right.
Because I think a lot of times people have it setting up the inequality the right way. They don't look at their equation as being the thing that we're talking about.
Right. So if you want to wait till the end to answer the question and say, you know, it has to be no more than 14 people or whatever, just as long as you indicate you know what you're talking about, we'll be happy. 359 says Kellen wants to rent a banquet room. The charge for the room is $350 plus $32.50 per person for lunch. How many people can Kellen have if she wants the maximum cost to be $1,500? So that means she doesn't want to spend any more than $1,500. Okay, so I'm going to do it like Matt was suggesting. We know that the room costs $350 plus $32.50 per person. So again, I'm going to let X equal the number of people. And we want the maximum cost to be $1,500. So that means I want this to be less than or equal to $1,500. But if that's confusing, don't worry about it till the end. Just say equals to $1,500. And then solve this problem just the same as we would always, 350 minus 350. So we have 3250 is equal to what? My brain is
1150.
1150. That sounds right. And then we're going to divide both sides by, and this X, divide both sides by 3250. So 1150 divided by 3250 is 32.39. But we, and okay, so if you do this, you get X equals 32.39. Well, we're talking about people, right? So always round up to the next person because we don't want to, if we round down, that means we're not going to have enough.
I'm getting 35 point.
Did I do it? Oh, because I divided by the wrong thing. Okay, 1150, thank you. Divided by 32.50. Yeah, thank you. 35.38. So we're going to say 36 people. Let's see. How many people can Kellen have? She wants the maximum cost. Oh, no, because we want the maximum cost to be $1,500. So we would have to round down, right? Because if you round it up, you'd be over 1,500. So she can have at most 35 people. Make sure that your answer makes sense. Because if we rounded up to 36, that would give us more than the $2,100, and we don't want that.
Yeah, and in general, when we have a word problem, I'd really like to see a response in English. Like she can have 35 people at most, something like that. Something that shows me that like you kind of understand what's going on, and you can take the number that you just found and come up with an English sentence in it, right?
Yep.
Yeah.
All right, then the rest of the problems come from 0.6, and they are, forget which ones they are.
Just picturing your boss asking you how many people you can have at the banquet, and you tell him X is less than 35. He's going to be so mad at you.
All right, so the ones that are left for you to do are 377, 397, and 403. And I'll run through them really quickly just on the off chance that you want to see these. So X is greater than or equal to 4, and X is less than or equal to 4, and X is greater than -2. So if we look at these two separately, X is greater than -2 would look like that, and X is less than or equal to 4 would look like that. So you can see that it's going to be everything between -2 and 4. Did we already do these? That looks really familiar.
Yeah, I think we did 377, 397, and 403.
Okay,
Or did we
okay,
skip
then
past
good.
them? They were on the paper.
Okay, I just probably, who knows what I did. All right, so we've done it. All right, so that's it, guys. And again, I will post this on Blackboard so you can look at it if you want. And then just make sure that you
They
do the
don't-
written sheet with it.
They don't give them any like empty intersections, do they?
I don't think they
Yeah,
do.
I didn't see any of those, but technically
Oh,
they
wait.
could.
No, yeah, okay, here, x is less than or equal, here is one, x is less than or equal to -4, or x is greater than -3.
That's an or. It's not an and statement, so that's
So,
a
so that would be a union, yeah.
yeah. It's not an
No, so
intersection.
no, we don't, right. Nope, there's not any.
Yeah, I mean,
Yeah, so this one would be, yeah, -infinity to -4, union, -3 to infinity. We already did that one.
test bonus question. See how many people get it.
Okay, any questions before we all sign off?
Give me 1 second. Let me see here. No, I didn't have anything.
Okay. All right, and Matthew, you've looked at the test and you think it's all in there, right?
Yeah, it looks good. It looks like it's covering everything.
Okay, cool. Then I won't worry about it. And y'all